Hello students, welcome to EDAMIGO, an initiative by GATE ESE Top 3 Rankers. I welcome you all to the lecture series on previous year GATE questions on the subject of signals and systems, electronics and communication, and the topic is basics of signals and systems. Here we are discussing the solutions of the previous year questions and as well as we are looking at the concepts behind the questions that will help you to know the concepts on which the questions are being asked in the GATE exams. We have already completed 5 parts of the lecture series and this is the 6th part of the lecture series. So let's begin with the questions. So this is the question. It is given that the impulse response of the LTI system can be obtained by. Now first of all, as we have an LTI system, the input is delta t, the output will be the impulse response that is called ht. Okay, now if we have the response of ut is the unit step response. If we give ut as an input to the same system, the output is st, that is called the step response. Okay, now since this is a LTI system, ut produces output that is called st. Since differentiation is a linear operation, so if we do a linear operation on the input, the same linear operation will be held at the output also. So if we differentiate the input, the output will also get differentiated, and differentiation of the ut is delta t, and thus by differentiating and we can see that by differentiating the input, that is ut, we are getting delta t, and thus the output of the delta t will be d by dt of st, and that is equal to ht. So we can say that by differentiating the step response, we will get the impulse response. So by differentiating the unit step response, we will get the impulse response. One more important point here it is that if we have a ramp signal having the output, let us say capital RT. Okay, now if we differentiate ramp, that is equal to ut. So ut will have the response equal to d by dt capital RT, that will be equal to the step response. Okay, now if we differentiate the ut, that is equals to delta t, so d by dt of st is equal to ht. Okay, now a very important point here it is that when we differentiate rt, we get ut. When we differentiate ut, we get delta t. So we can say that ht is equals to single derivative of the step response and will be equal to double derivative of the ramp response. Okay, so it is not equal to, so impulse response is equals to differentiating the step response, but it is not equal to differentiating the ramp response. Rather it is equal to double derivative of the unit ramp response. Okay, so this explains the answer. This is the next question. Okay, here given that xn is equals to sine pi square n, where n is a integer. Okay, so solution, xn is equals to sine pi square n. Now Since it is periodic, let us say the period, let us assume that it is periodic with period capital N. So xn plus capital N should be equal to xn. Okay, so sine pi square n plus pi square capital N should be equal to sine pi square n. Okay, now as we know that sine omega naught n plus theta is equal to sine of omega naught n when, so this is a condition which will exist when theta is equals to an integer multiple of 2 pi, that is equals to 2 pi m, where m is any integer. One more important point here, it is xn, that is a discrete signal, is periodic with period capital N, and the condition is that n is an integer. N has to be an integer, okay, because it's a discrete signal. Now this is the condition that is valid when theta is equals to 2 pi m, where m is any integer. So this condition will be valid when pi square n is a integer multiple of 2 pi. So pi square n should be equals to 2 pi m. Now in this condition, m and capital N both are integers. So n upon m is equals to 2 pi upon pi square, that is 2 upon pi. Since n is an integer, m is an integer, this ratio should have been equal to integer upon integer ratio if the signal was periodic. But here we can see that the ratio is not integer upon integer, rather this is an integer number and this is an irrational number, which is pi. So n upon m, that should be an integer upon integer ratio if xn was periodic. But since this is not coming out to be integer upon integer ratio, so sine pi square n is not a periodic signal. Okay, it is not a periodic signal, it is non-periodic. Okay, one more thing, as I have told you in the previous part of the lecture series, that sine sigma n or cos sigma n is periodic when sigma is product of a ratio which is integer upon integer multiplied by pi. But if we compare here, we have sigma is equals to pi square, that is pi into pi, and this is an irrational number. So sigma is not equal to integer upon integer ratio multiplied by pi. So that's why we can say that here sine pi square n will be a non-periodic signal. Okay, now let's move on to the next question. So this is the question. Here it is given that xn is this signal and xn is convolved with itself. So yn is a convolution of xn with itself. We have to find the value of y4. Okay, now in the previous part of the lecture series, I've already told you how to find the convolution of two discrete signals. So we will write, so there are 10 terms. We will write x0, x1, x2, x3, x4 and so on, like this: x0, x1, x2, x3, x4 and so on, and then we will multiply these terms, write them, and the first term will give me y0, the second term will give me y1, y2, y3, y4 and so on. So we have seen the method. So I will just write the solution. So xn convolve xn will be equal to, so the values are 0, 1, 2, 3, 4, 5, 6 and so on. 0, 1, 2, 3, 4, 5, 6 and so on. Now we will multiply 0 with all the terms. We will get 0 everywhere. We will multiply 1 with 0. So we will get 0, 1, 2, 3, 4, 5, 6, 2 cross. Then we will multiply 2 with everyone. So 0, 2, 4, 6, 8, 10 and so on. Then multiply 3 with everything. 0, 3, 6, 9, 12 and so on. Then multiply 4 with everything. So we'll get 4 multiplying with 0, 4, 8, 12 and so on. Again the cross 0, 5, 10 and so on. Okay. Now other terms will also be there, but they will put cross like this. Okay. The cross will be like till here, and then again the cross will be till here. Okay. So other terms will not affect the result. Okay. So now if we want to find the, so this will give me y0, y1, y2, y3, y4. Okay. So y4 is actually the sum of these terms, and the other terms will not affect it because they will all put cross in this column. Okay. So y4 will be equal to 0 plus 3 plus 4 plus 3, and this will give me the answer 10. Okay. So 10 will be the answer to the question. Okay. So this is the correct answer. Y4 is equals to 10. So we have solved this question also. So okay, so 10 is the answer to the question. So we will stop here and we will solve more questions in the next part of the lecture series. So thank you students. Give us your feedback and keep sharing these lectures. Thank you.